Hello again. We are continuing our discussion on exponential functions by talking about the properties of those exponential functions. So let's get started. The standard form of exponential functions is always going to be f of x or y equals some constant a times another constant b raised to the x, where x is your variable. So we are going to find the y-intercept of this exponential function, and we're going to do that by setting x equal to 0, just like we always do, and solving for y. All right, so for example, if I have f of x equals 2 times 3 to the x, then what I'm going to do is I'm going to set x equal to 0. I realize that a is equal to 2 and b is equal to 3. So to find the y-intercept, I'm setting x to 0, so now it becomes 2 times 3 to the 0. Well, 3 to the 0 is 1, and if I multiply that by 2, I get 2. So my y-intercept is going to be 2. All right, another example, if I have f of x equals negative 5 times 0.4 to the x, I realize that my a value is negative 5 and my b value is 0.4. So to find the y-intercept, I set x equal to 0, and I get negative 5 times 0.4 to the 0. 0.4 to the 0, again, is going to be 1. And if I multiply that by negative 5, I get negative 5. So the y-intercept for this second function is going to be negative 5. All right, now let's talk about the domain and range of exponential functions. The domain is always going to be all real x's because I can plug any real number into that function and get an output for it. All right, but the range is going to change depending on the value of a. So if you have an a value that is greater than 0, then your range is going to be all y's that are greater than 0. And if you have an a value that is less than 0, then the range, again, is going to change, and it's going to take on all y values that are less than 0. So for example, if I have f of x equals 2 times 3 to the x, just like the first example I had before, the domain is going to be all real x's like it always is, and since my a value, which is 2, since that's bigger than 0, then my range is going to be all y's bigger than 0. Okay, the second example I had was negative 5 times 0.4 to the x. The domain, again, is going to be all real x's, and since my a value, negative 5, is less than 0, then the range is going to be all y's that are less than 0. All right, so now let's talk about the last property, which is end behavior. In all exponential functions, what makes them different is that one end of the graph goes off to either positive or negative infinity, and the other end approaches a horizontal asymptote. That's true of all exponential functions. And which end is which, and whether it goes to positive or negative infinity, depends on your values of a and b. All right, so let's look at all possible cases. So if you look down the left column, I've got both possibilities for what a could be. It could be bigger than 0, or it could be less than 0. And then along the top, I've got values of b. B could be greater than 1, or b could be between 0 and 1. We're not going to talk about negative values of b. That's a topic for another level of mathematics. We're only going to be dealing with positive values of b, and we're going to separate those into the b's that are greater than 1 and the ones that are between 0 and 1. All right, so if my a value is positive and my b value is greater than 1, then the graph is going to have a horizontal asymptote on the left-hand side, and it's going to go up towards positive infinity on the right-hand side. All right, so we can say that as x approaches negative infinity, which means we're going to the left, y is going to approach that horizontal asymptote of 0. And then as x approaches positive infinity, meaning that it goes up to the right, then the y values are also going to approach positive infinity, meaning they're going to go up and up and up without any kind of limit to where it stops. If my b is between 0 and 1 and my a value is still positive, then it's going to be a mirror image of that reflected over the y-axis. And so as you can see, as I go off to the left-hand side, now the graph goes off towards positive infinity. So another way of saying that is as x approaches negative infinity, then y approaches positive infinity. And then as I go off to the right, now this time it levels off at that horizontal asymptote of 0. So as x approaches positive infinity, y is going to approach 0. All right, here's the third possibility. Now I'm dealing with negative values of a, but still b values that are greater than 1. And so you'll see now this is a mirror image of the very first graph, but it's reflected in the x-axis. So again, as I go to the very, very left, the y values are still approaching that horizontal asymptote of 0. And as I go off to the very, very right, this time the graph is going down and down and down and down and approaching negative infinity. So that's the end behavior for that graph. And then finally, you can probably guess what the last possibility is. Here's a graph of it right here. This is where the a values are still negative and b is somewhere between 0 and 1. Okay, so as I go off to the left, the y values approach negative infinity again. And as I go off to the right, the y values approach that horizontal asymptote of 0. All right, so those are the 4 possibilities. Now here's an example. I'm actually going to go through the whole thing and graph it with you. If I have f of x equals negative 2 times 3 to the x, then my a value is negative 2 and my b value is 3. The y-intercept is going to be what that's worth when x equals 0. So I will replace x with 0. 3 to the 0 is 1, and 1 times negative 2 is negative 2. So that's my y-intercept. The domain is going to be all real x's, just like it is for all exponential functions. Since my a is less than 0, then the range is going to be all y's that are less than 0 as well. So here's a table of values that I made. I plugged in negative 1, 0 I had already plugged in before. I plugged in 1 and I plugged in 2 and I got those y values. So there is the point negative 1 and negative 0.667. Here's the point 0 and negative 2, 1 and negative 6, 2 and negative 18. And so you can see that if I join those points and keep the graph going, it's going to look something like this. All right? So the end behavior, you can see that as I go off to the left, as expected, the y values will approach a horizontal asymptote of 0, and as I go off to the right, the y values will approach negative infinity. All right, another example. If I do f of x equals 4 times 0.5 to the x, you will notice that the a value is 4 and the b value is 0.5. Okay, so the y-intercept, again, I'm going to let x equal 0, and I get 4 times 0.5 to the 0. Which is 4 times 1, and that is 4. So I have a y-intercept at 4. The domain is going to be all real x's, and since a is bigger than 0, it's 4, the range is also going to be all y's that are greater than 0. So here's a table again. I plugged in the same values of x and got those values of y. So let me just plot those points. Here's the point negative 1 and 8, 0 and 4, 1 and 2, and 2 and 1. And as you can see, the graph is going to look like this. So as I go off to the left, the y values are going to approach positive infinity. And as I go to the right, the y values are going to approach that horizontal asymptote of 0. So here are just some examples of how to use the properties of exponential functions to help you graph them, to help you see what's going on in the function. So if you have any questions about that, please let me know, and I will see you tomorrow.